Welcome to another video on control system. We will continue with Nyquist plots. Before we go into the exact problems, you have a look at these prerequisites. Okay, after these prerequisites, let us take up this interesting problem. So we shall have a quadratic term which represents a complex poles. So I have poles at origin, repeating poles, and this is at -2 and plus or minus of j 9 point something, and I have a 0 at fine. How does the Nyquist contour in S-plane look like? This is Nyquist contour in S-plane. This is a Nyquist contour in S-plane. So I will end up with, let me see whether this is visible or not. Okay, let me not go into the basics of this. So this is already known to you people. So let us start. Only thing here is that when I'm substituting s by j omega for this quadratic term, let us spend some time here. Okay, let me just write it here. So this is 100. This is 2 plus j omega. This is minus omega square, and this happens to be minus omega square plus j 4 omega plus 100. So then this magnitude will become, because this minus you can put it as, so suppose you are looking at magnitude only, then it is 100 multiplied by omega square plus 2 square divided by omega square under root of this is now 100 minus omega square whole square plus of plus of, so what I have, this is uh, 4 omega whole square, 4 omega whole square. So that happens to be the magnitude. When it comes to phase angle, it is minus 180 degree plus of tan inverse of omega by 2 minus of tan inverse of 4 omega divided by 100 minus omega square. This is for all values of omega between 0 and 0 and 10. 0 and 10. For values of omega more than 10, for values of omega more than 10 radian per second, the phase angle will be minus 180 degree plus of tan inverse of omega by 2 minus of 180 degree minus tan inverse of 4 omega divided by omega square minus 100. So this is the change. Here it is now, here it was 100 minus omega square, now it will become omega square minus 100. So now this and this will become minus 360, which you can cancel it out and get as it is tan inverse of omega by 2 plus of, this is, now you can see this will become plus tan inverse of 4 omega by omega square minus 100. Correct? See, this is plus here, and this is minus into minus, that is also plus tan inverse of 4 omega by omega square. This is for all values of omega greater than. Correct? Now I can actually find out what is. So let me find out for different values of omega what is magnitude and the phase angle. For omega 0, this is the denominator will become 0. That means the magnitude is infinite. The phase angle you can consider this. So then this is 0. This is also 0. It is minus 180 degree. When it is infinite, the magnitude becomes 0. So when omega is infinity, I have to consider this equation. So if you substitute this omega as very large value, then this tends to 0. So then this will become 90. So exactly plus 90 degree. Correct? Here, when omega is tending to infinity, this is infinity square minus 100. Here it is 4 infinity. It actually becomes infinity by infinity square. So then this is actually 0. So tan inverse of 0 is 0. So this is tan inverse of infinity is 90 degree. So that's why it is plus 90. Correct? And we can actually find out for point 1 what happens. For point 1 what happens. So for point 1 you can use this equation. You can see now since plus is uh, dominating here compared to minus, let us see what happens to the phase. So it is minus 180 degree plus tan inverse of, so the pole is at minus 10, whereas of course the complex there are repeating poles at 10 radian per second and there is a 0 at 2 radian per second. So this is actually dominating. So tan inverse of zero point 0.5 alpha a minus of tan inverse of open the parenthesis 4 alpha a divided by open the parenthesis 100 minus alpha a square close. What I have to do? I have to do that. Okay, calculate for point 1. At point 1. You can see at point 1 it is minus 177.36 degree. So if you keep increasing, so at the 10, what will happen? Maybe at 9.9999 it is minus 191. Minus 191.3 is at 10 radian per second. At frequency this, you can see between this it is already crossing minus 180. I can make this, I can make it alpha equals minus 180 and then try to find out. Okay, what I'll do, it is alpha equals minus 180 shift can. At what frequency this will become minus 180? That's what is omega PC. Omega PC is 9.59 radian per second. So omega PC is 9.59 radian per second. Fine. Okay, done. And then of course I can find what is omega GC also. Where is the magnitude becoming 1? So that is omega GC. Let me find out that. How do I find out that? Equate this magnitude to this and try to get, okay, now 100 into, open the parenthesis, into, sorry, okay, under root of, sorry, under root of this is alpha a square plus 2 square close alpha equals, this is alpha a square multiplied by, open the parenthesis, square root of close, maybe one more open, 100 minus alpha a square close square plus of okay okay plus of open the parenthesis 4 alpha a square close hopefully that is enough. Shift cal okay, this happens to be my omega gc. It is 1 point sorry this is 1.625. At 1.625 I have just a minute square 100 minus square 4 alpha. Okay, so this is what is at so on and let me find out what is at 9 point something. What is the magnitude? So this is magnitude 1. So now let me say this is divided by calculate at 9.59. I think something went wrong there. It is 100 divided by and root of that divided by oh, okay. Let me just redo this. So I'm just trying to find out what is 100 multiplied by open the parenthesis square root open the parenthesis alpha a square plus 2 square close alpha equals open the parenthesis alpha a square multiplied by open the parenthesis okay square root of open the parenthesis another open okay 100 minus alpha a square plus 4 alpha a square this close shift can is 1.625. This is omega gc fine. And then what I have to do, this is omega gc. Where is omega? I have to divide this by I have to divide this and calculate at 9.59. Okay, I have it as 0.271. So at this magnitude at omega PC is 0.271 radian, which is 0.271. Correct? Okay. Now let us plot this. How do I plot? This is my GH plane. The phase actually goes from minus 180, again goes to this is how it is going, and it's again going here and then going at plus 90. This is plus 90. Correct? That's how it goes. Sorry, this is this. this point magnitude is 0.271, and of course if you can actually find out that, it will be a dot at the origin, and then if you again write its mirror image, it will be this. It will actually go like this, correct? So minus 1 will actually come here, minus 1 plus a 0. Second segment, I just assumed it as 0 at an angle zone, so you can just prove that also. So it is 100 r e power j theta plus 2 divided by r e power j theta whole square into r e power j theta, this is square, this is 2, plus 4 r e power j theta plus 100 plus 100. So that will become 100 r e power j theta. This is r power, this will be 0, this will be 0 compared to this, then it is r cube or r to the power 4 e j 4 theta, correct? So then this will become 0 at an angle minus 3 theta. So theta ranges from, so it is 0 at an angle minus 270 degree, 0 plus 270 degree, 270 degree. So meaning this is a dot at the origin. So because minus 270 is nothing but 90 degree. So it ended at minus, sorry, plus 90 degree. It is starting at 90 degree. So this is the dot, 0. This is minus 90 degree. So it starts here and then goes like this. So this is second segment. Second segment. How about the fourth segment? Fourth segment is S is rho e power j phi. So it is now, take this equation. As per this equation, now it will become 100 rho e power j phi plus 2 divided by rho square e j 2 phi. This is rho square e j 2 phi plus 4 rho e power j phi plus 100. And r is tending to 0, so these two will tend to 0. Now this will become 100 into so on. So this 100 will become, when you multiply with 0, that will become negligible. So now this will become, okay, this is now negligible. You see now it is infinity at an angle minus 2 phi. This only, this phi will go, 2 phi will go there up. So it is, so now it is, phi is ranging from minus 90 degree, minus 45 degree, 0, plus 45 and plus 90. So then this will become minus 180 degree, sorry, this minus into minus will become plus. It is plus 90 degree, 0 degree, minus 90 degree and minus 180 degree. So now this is the fourth segment. It is coming this point. Can you see this is infinite angle plus 90? It will go to infinite angle 90 degree. So it actually goes like this. This is infinity. It goes like this. This is minus 1 plus j 0. So minus 1 plus j 0 is not total n circle. So n is actually how much? So n is 0. N is 0. So what do you mean by n0? So n0, what is p? P is also 0. What is that? That is n plus p, which is now 0. Which is now 0 here. And this system is, the system is infinitely absolutely stable. No, it's not absolutely stable. If you increase this 100 by, what is the gain margin? Gain margin nothing but 1 over 0.271. So what is 1 over 2? 0.217 or 271, 0.271 1 over that is, it is 3.69. So if the existing gain, if it is multiplied by, if it is 369, then the system is oscillating. The system is oscillating. That is, existing gain is 100. If you multiply it by 3.69, it will become 369. Then the system is oscillating. If it is more than 3.69 times, suppose this becomes 500. When it becomes 500, then n becomes, when n becomes 2 means system is unstable with two roots lying onto right hand side. Anyhow, p is 0. When n is 2, z also becomes 2. System is unstable because two poles go to right hand side of the spine if the value of root locus gain becomes 500, or anything more than 369, you have two roots to the right hand side. That's what is system stability, gain margin, and phase margin. Correct? Sorry, we have not yet found the phase margin. So how much is phase margin now? So to find the phase margin, it is 180 degree plus the phase at omega GC. It is now 180 degree plus what is phase at omega GC? Can you see this is omega GC? It's at minus, it's minus 177.36 degree. Is it this much? Okay, you hardly have a phase margin of 3 degrees or less than that. So just verify this. So I have done the calculation. This is how you should do. So maybe you can just verify in your MATLAB also. It is 180 degree. So it is 180 plus of or it is minus of 177.36. You see it is 2.177.36 comes out to be plus 2.64 degrees is your phase margin. So you have a phase margin of, so gain margin of 3.69 is the gain margin, or in terms of dBs, do it as 20 log of 3.69, so many dBs. So this is gain margin. System is stable. System is stable. Just verify these values once. Okay. So we will see another interesting problem here. So that one is, let me just, okay, this is GFS into HFS is 800 S into S minus 1 S minus 2. Let us see what that is. So this is 0 here, 1, 2. I have determined P is actually 2 now. P is actually 2 now. First segment mapping, it will be 800 omega by omega square plus 1 and omega square plus 2. Correct. So phase is plus 90 degree minus of 180 degree minus tan inverse of omega minus of 180 degree minus tan inverse of 0.5 omega. This will become plus 90 minus 180 degree plus tan inverse of omega minus 180 degree plus tan inverse of 0.5 omega. So this you can anyhow cancel out. This will become 90 degree plus tan inverse of omega plus tan inverse of 0.5 omega. Correct. This is 5. Oh, magnitude is also given. Let me write the table corresponding to omega, magnitude and phase. 0, infinity. So if it is 0, it is 0. If it is infinity, it is 0. If it is so now this is interesting. So when it is 0, it is plus 90 degree. When it is infinity, it is plus 270 degree. Correct? So this is now, what is this? So it is 800 alpha A divided by okay, under root of open the parenthesis alpha A square plus 1 close into on the parenthesis under root of alpha A square plus this is simply 2 square. This is 2 square close. Calculate for point 1. Point 1 it is 39.75. Calculate at point not 1. Point not 1 it is 39 point, sorry, 3.99. 3.99. Correct? 3.9. Fine. And this is calculate at 1 it is at 250. Calculate at 100 it is, you can see at 100 it becomes 7.98. It starts reducing, so it actually goes to a very large value and then comes down. It is 90. The phase angle is keep increasing. At some point it will become 180 degree. So now how does the plot goes? So it is so this is 0 degree plus 90 degree plus 180 degree. This is plus 270 degree. It actually goes like this. This is going all the way, and at some point it goes there, and then again it just goes here. So this is how the this is 90. Can you see this is increasing? This is plus 180 or at 180. Okay, let me just okay. Would have found okay. Equate this to 180 degree and then find out what is omega PC. Now let me equate, because this will never become sum minus 180 degrees both the same. Let me equate these two. 180 alpha equals 90 plus tan inverse of alpha A plus of tan inverse of zero point 0.5 alpha A shift cal. So that happens at omega PC now you're looking at it is 1.414. So at 1.414, you can see at 1 it's around 252. So at 1.4, this is certainly greater than 1. So the minus 1 plus 0 comes inside this. So this is the first segment. So this is interesting. So first segment is here. How about the second segment? Second segment would be a dot at the origin. It will be here only. How about the third segment? Third segment would be just the mirror image of this. So what do you mean by mirror image? So mirror image is, so it actually went like this. This will actually go like this. So this is exactly overlapping. This is actually overlapping. So whatever is the image you have, this was actually going like this. Now it actually goes the other way. Goes the other way. So it's here now. Then how about the last segment? Last segment is, so it is 800 rho e power j5 divided by rho e power j5 minus 1 rho e power j5 minus 2. This will go off, this will go off, minus into minus will become plus, and this will become 0 at an angle, 0 at an angle. So now let us see what this. Okay, now if you can see this, so this is, if it goes like this and then comes down, this is the mirror image is exactly, this is the mirror image of this. So mirror image of this would be exactly the same thing. You can see this is the mirror image. The mirror of this, suppose if you put the mirror of this one, so it's exactly the same. So it actually goes this way only. Can you see this is actually going this way? So it's actually in the same direction. So here it is 0 at so on, so it's again a dot there. So now what I have is, this is my plot, this is my like this plot. So now actually p is equal to, if it was, okay, let me just again clarify. This was my first segment uh, mapping onto GH plane. Second segment is a dot at the origin. Third segment is just the mirror image. Mirror image means, so if I put a mirror for this one, whatever is this, so will actually replicate here. So it actually going like this. Can you see it again goes this way? And this was actually going like this. It's exactly goes in the same direction. If you can actually see, this is once, twice, n is actually minus 2. So because it's going in anti-clockwise direction. So n is minus 2, p is actually 2, then that becomes n plus p, n plus p, which is minus 2 plus 2, it will actually become 0. So now z is equal to 0, meaning that system is stable. System is stable. Suppose you actually write the root locus of this one. So what happens to this? Can you see it will actually break here, and then root locus actually comes like this. This is how the roots are going. I have taken the value of this k as 100. When k is 100, the poles are already there, came onto the left hand side. So that's why the system is stable. System is stable. So if I take a lesser value of k, then the minus 1 actually comes out. P will be 2 only. System will be unstable. System will be unstable. But you can certainly find out what is GM and PM. I'll just give it as an assignment, or you can just work it out. Verify the same thing with your what MATLAB. Find the value of GM PM. Verify it in MATLAB. You can certainly get the values of GM PM. So this is really interesting. The n value is -2 for this particular problem, and you can see that becomes that becomes 0 then. When that is 0, system is stable. I'll just leave it to you to find the gain margin, phase margin. So gain margin is nothing but 1 over the magnitude at omega PC. Now omega PC you are looking at plus 180 degree because it is plus or minus 180 degree. This minus 1 corresponds to 1 at an angle plus or minus 180 degree. Plus or minus 180 degree. So far we are considering as minus 180 degree. Now we are forcefully considered as plus 180 degree because this phase will never become minus 180. Because we know that either it is plus 180 or minus 180 both are same. That's why I'm equating these to plus 180 degree. So that's what is omega PC corresponds to plus or minus 180 degree. Now in this particular problem it is plus 180 degree. Fine. Okay, that's good. Okay, we shall see few more problems in the next video. Thank you.